So my guess, so for those of you who actually did this, how long did it take you to do this practice test? 40 minutes? Less? Okay, then that's all, right? So tomorrow's test, you should do it in less than 40 minutes, right? And you can hand it in and go to the snack bar or early lunch. Tomorrow's mochiko chicken. Oh. Except this doesn't come right before lunch, though. So.
Yeah.
Soccer. Okay, so I'm gonna do every single problem on the practice test. So we can get it on the video, and then you guys need to know how to do this. Yeah. So wait, I gotta make it bigger so I can actually see it. So hopefully I can see that. Now I noticed on the quiz. Now, some of you kind of cheated. You didn't really cheat, but you didn't really complete the square. You know what I'm talking about? Tomorrow, you actually need to complete the square. Or, because even if you get the right answer in Vertex form, I'm not going to take out points because you didn't complete the square. So, y equals 2x squared minus 20x plus 15. So, first step, you look at the first two terms. What can I factor out? 2. Yeah, so whatever this number is, you factored it out, 2. So you get x squared minus 10x, leave a space, plus 15. Now what do I have to add right there to make a perfect square? Yeah, you take half of this number, which is negative 5, and you square it with 25. But what did you actually add? You added 2 times 25, which is 50. So if you add 50 there, then you have to subtract 50 to keep it the same as the original, right? Because a lot of people put plus. Well, what would happen tomorrow if you put plus 50 there? Well, yeah, I know. How many points would come? Like if this problem is worth 6 points or 8, no, let's say 8 points. This problem is worth 8 points. How much would you get off by putting a plus 50 there? Minus 1, 2, 3, or 4?
4.
Yeah, I would say 3. 3. I think 3. No, you're right. 4. 4. So 2, and then this is a perfect square, right? And then minus 35. Box your answer. You know why? Because it says so. Doesn't it say box your answer? It didn't say. Okay, tomorrow's one should box your answer. Okay, number 2. Graph. Okay, this is probably going to be worth 10 points because you got to do lots of stuff. Okay, and you got to show with the whole. In fact, this might be worth 12 points, this problem, because, like I said, you got to do lots of stuff. So what's the most important point of a parabola? A vertex. Where is it? Negative b over 2a. So what is that? 12 over 6, which is 2. How do I figure out the y-coordinate? You plug it in, so you get 12 minus 24 plus 7, that's negative 5. Did I do that correctly? Okay, so 2, negative 5. The vertex. And it's going to open upward because the leading coefficient is positive. But like I said, that's not good enough. You can't just make it open upward. You got to show the y-intercept, right? This number is the y-intercept. 1, 2, 3, 4, 5, 6, 7. So if you go 2 to the left and you're up there, if you go 2 to the right, you should be up there as well. So it's a really kind of thinner parabola. Then you gotta, so here's the y-intercept, so you gotta label it, and then the x-intercepts. How do I find the x-intercepts? Set y equal to 0. Now, is that factorable, or do I have to use the quadratic formula? Oh, Mr. Park, every time we do this problem, I'm gonna use quadratic formula, so I'm probably gonna do it tomorrow then, right? So, x equals negative b plus or minus the square root of b squared minus 4 times 21, which is 84, all over 2a, which is 6, but that comes out to 60. And how do you simplify the square root of 60? 4 times 15, so 2 root 15. And then can I just cancel out 2's? 2 cancels that, 2 goes into that 6 times, and 2 goes into that 3 times. So 6 plus or minus root 15 over 3. So the x-intercepts are, this one is 6 plus root 15 over 3 comma 0. And the one on this side is 6 minus root 15 over 3 comma 0. Then it says state the domain and the range. So domain. What is the domain? A domain is a listing of all the x coordinates on the graph. All real numbers. So there's lots of ways you can do it. You can do this. All real numbers. Or you can put negative infinity to infinity. Or you can just put the capital R. They all mean the same thing. All real numbers. Range. Range is a listing of all the y coordinates on the graph. What's the smallest y coordinate you have on the graph? -5, and then it just keeps going up all the way, right? So the easiest thing to do is go y such that y is greater than or equal to -5, or you can write bracket -5 to infinity. They both mean the same thing. I don't care how you write it. And then it says determine when it's increasing or decreasing. So when is this graph increasing? In other words, going uphill. Well, from the vertex and to the right, right? See how the graph is going up? So what is the x coordinate right here? So everything to the right of 2, so it would be from 2 to infinity. Where is the graph decreasing? That means where is the graph coming downhill? Well, would it be to the left of the vertex? So where would that be? Negative infinity to 2. Bam! This problem probably requires the most amount of work. Yes?
For increasing and decreasing, can I write like x greater than 2?
Yeah. So if you don't like this, x is greater than 2 is fine, and then over here, x is less than 2. They both mean same thing. Yep. As long as it's correct mathematically, you'll get the points. Okay, I'm going to erase. Okay, next problem. So you guys lucky I gave you practice quiz, practice tests. I had to give you guys high grades. Don't you guys want high grades? Okay. Okay, come on. This is like the last quiz right here. The first 4 problems is the last quiz. Okay, number 3. Write the equation of the parabola. The vertex is at 5, 2, and it passes through this point, and write your answer in vertex form. That's like kind of like a hint, right? So, since you know what the vertex is, what is vertex form? A times x minus 5 squared plus 2, right? How do I figure out what this is? You plug in the point. So if I plug in -1 for x and -6 for y, can I figure out what A is? Yes. So -6 is equal to, so that's -6 squared, 36a plus 2, subtract 2, it will be -8. Just do the algebra correctly. Divide. You know what you should do? A lot of people, they're just making mistakes on this part of here. Like actually divide 36 and then reduce it. This can be reduced by 4, so 2 9ths, negative. So your final answer is y equal -2 9ths x minus 5 squared plus 2. Box that, that's the answer. This is probably the easiest problem on the test right there, yeah? Or is it number 4? Number 4 is pretty easy too. Here's a, now you're not going to get to use a calculator, so I'm going to give you nice numbers to deal with. Like the one, remember the ones in the book was ugly? I'm going to give you nice numbers. This is a revenue function where x represents, what does it represent, how many items you're selling, yeah? So, if I were to graph this, this would be a parabola opening downward, so there is a maximum revenue that you can make over here. And how do I find this maximum point, which is the vertex? -b over 2a. That comes out to 6. How do I figure out the y coordinate? Plug it in. Okay, no. Let's see if we can do this. But plug in 6. 36 times 4 is 900. So -144 plus 46 times 6, 48 times 6 is 240, but that's 288, yeah? Plus 36. If you can't do it in your head, don't worry. Just go on the side and compute that. But this plus this is 144 plus 180. Okay, I don't care what arithmetic you need to do, just get those numbers, yeah? So now you answer the question. What's the question? How many items should you sell to maximize your revenue? 6. That's kind of dumb, yeah? What are you selling? And then what is your maximum revenue? $180. But like I told you yesterday, in real life, you're not gonna, if you're a business person, you're not gonna just sell 6 things, right? So this probably means 6,000, and this would be like 180 million, maybe? I don't know. Yeah, that one was pretty easy. But here is where students get stumped. Even though we did it before multiple times, the word problems. Okay, now these are the same word problems we had on the homework. So you got them on the homework, you got it on the practice test. Should be able to do it, right? So we have a barn over here. And then we're gonna make a rectangular enclosure because we have like sheep or goats or whatever we have there. Now, I make it easy for you, like I'll put in the letter so that you don't even have to think, okay? It says, what is the maximum area that you can enclose over here? Now this is a so we want to maximize the area. So how do you find the area of a rectangle? X times y, length times width, right? But the problem is there's 2 variables, so you need to write another equation to get rid of one of the variables. So what, you need more information. Well, there's 200 feet of fencing available. This is the fencing right here. This is the fencing. That's 200 feet. Because you don't need a 4th side because you're using the barn as a 4th side, right? So what equation can I write? This plus this gotta equal, what number did I use there? 200. So what? 2x plus y gotta equal 200. See, if you write that down and that down, at least you're gonna start building points, yeah? Now what do? Solve for y in this equation. Take that and plug it in right there. So the area is equal to x times 200 minus 2x. And hey, it's a quadratic function. That's what we're studying this chapter, right? Multiply it out. So you get what? 200x minus 2x squared. And if you need to, most of you don't need to do this, but if you need to, put it in order. Put the x squared term first, put the x term second, and the constant last. But there is no constant there. Now, if I were to graph this parabola, it would be facing down, and then see there's a maximum point. So there's a place where you can have maximum area. So how do I figure out the vertex? Negative b over 2a. That comes out to 50. And then how do I figure out the y-coordinate? You plug it back in. Now think about it. If I had to plug in 50 into here, that's a lot of work. But all 3 of these are the same. Isn't it easier just to plug in into this one? To me, this is the easiest one up here. So if I plug in 50, you're going to get 50 times, what is 2 times 50? Subtracted from 200. See, look at that. Anybody can multiply it by 100, right? Just tack on 2 zeros. So it's a 50 with 2 zeros. Now you got to answer the question. The question says, what is the maximum area that you can enclose? So what is the biggest area that you can have here? What's the answer? 5,000. So the answer is 5,000. What if the question was, what dimension should you use to enclose a maximum area? Well, x has to be 50, so this would be 50, this would be 50. How do I figure out where y is? Go back to this equation, right? 2 times 50 is 100, subtracted from 200 is 100, so the answer would be 100 by 50. So just make sure, once you find the vertex, you just answer whatever question I give you. Okay, so like tomorrow, maybe I might just change it a little bit by, what if I did this? What if I did this? Let's say instead of goats, what if you have goats and sheep? So you want to separate it, like you want to divide it so the goats stay on this side and the sheep stay on that side, right? How would that change the problem? Is the area of the rectangle still x times y? Yeah. But what about the amount of fence that you have? Because now you got to put a divider over here, right? So they don't like commingle and start trying to mate and things like that, right? So what equation is it then? Instead of only 2x's, what do I got? Yeah, so it's going to be, the difference would be, that would be 3x plus y equal 200. But can you see it's like the same problem, right? So yeah, so I just changed just a little bit. I think you guys can handle that. Well, we'll find out, won't we? Okay, next word problem. Hey, Mr. Park, how many times are we going to do this word problem? Okay, so, you guys remember doing this on the homework? You made me do it on the board. You have a rectangle, and then you have a semicircle here. I guess this should be a dotted line. And then you have a semicircle here. So this is like a track right here. It's like our track out here. Okay? So, the inside perimeter of the track is 500 meters. So, this distance here, like that, that's 500. Well, in real life, what is the distance around the track? 400 meters, right? Okay, X represents the radius of the semicircle. So X, don't worry, tomorrow I'm going to give you a picture. In fact, here, this is the exact picture I give you tomorrow, right there. Give you that picture. Okay, now, what are we trying to maximize in this problem? What does it say? Write the area of a rectangle. So we got to write the area of the rectangle now, not the whole thing, just the rectangle. So, look at this picture. What is the area of this rectangle there? 2x, which is the height, and y is the base. There you go. What if I forget the 2, Mr. Park? Minus 2 or 3. 97 is a darn good score, right? Now I need another equation to get rid of one of these variables. So that's where this thing, the perimeter of the track all the way around is 500 meters. So what is this and that? What is 1y plus 1y? Okay, now this is one circumference. Now what's the circumference of a circle? Circumference of a circle is 2 pi r, right? So here's half a circumference. Here's half a circumference. Put them together, you get one circumference. So that would be 2 pi times the radius, but the radius is x, right? So the distance all the way around gotta be 500 meters. Can you solve for y? Now what do you want to do? You want to just move it over, or can you see that you can divide everything by 2? You want to divide that now or do it later? Doesn't matter, that's why. Do it now, okay? Divide everything by 2. Move that on that side, so y. So no matter what you do, I don't really care what you do, just get there. Take this, plug it in. So the area of this rectangle part is equal to 2x times y, but we just figured out y is this thing right there. Bam! Hey, it's a quadratic function. That's what we're studying. So if I distribute the times to 2x, you get 500x minus 2 pi x squared. And I'm going to put this in order. So put the x squared term first, put the x term second, and there isn't a constant term, so that makes things a lot easier. And so if I were to graph this, again, it would be a parabola opening down. So there is a point up here that is the maximum. You can have a maximum area, if that's what you want. Okay, so how do I find the vertex of this parabola? Negative b over 2a. Here's a. What's 2a? Negative 4 pi. The negatives cancel out, and 4 goes into 500. If you had $5 and you divide that among 4 people, each person gets $1.25. I don't think we're good. Okay, so 125 over pi. 125 over pi. So we know the x-coordinate of the vertex is 125 over pi. How do I figure out the y-coordinate? You would plug it back in, but do you need to plug it in this problem? No, because there. I answered all the questions already. Look, A, write the area as a function right here. This is the answer for A. Part B, find the value of x so that the area of the rectangle is a maximum. That's the answer right there. So if you want this area to be as large as possible, you would make x, which is the radius, 125 over pi meters. See how I make the problem easy for you? If I was a mean teacher, you know what I do? I make you take that and plug it in. But it's actually, if you remember the homework, it wasn't that bad, yeah?
solve for x? Or
Wait, let me look. Find the value of x, yeah. You guys have problems reading, yeah? So that's the problem in this class. We're gonna have problems reading. And then the last thing on the test is solving inequalities, but we just talked about that yesterday, yeah? The key to solving inequalities is you gotta make one side 0. So here, problem 7a. 3x squared is less than x plus 2. So the first thing I'm going to do is I'm going to make one side 0. Because that's what Mr. Park said. And then you want to factor that if possible. If cannot, then you got to use quadratic formula. But is that factorable? You bet your bippy it is. So you factor this thing. 3x, x, 2 and 1, minus plus. For some of you, this is the hardest part of the problem. Yeah? Now what? What did I teach you to do here? Make a number line. What goes on the number line? The zeros. What makes that thing 0? What makes that thing 0? And now, there's two things you can do. You can plug in numbers, or you can think of the graph. Now, if I were to graph this, it's a parabola opening upward, right? So it's going to look like that, right? So it's above plus, below minus, above plus. Or if you don't want to look at the graph, plug in numbers. Think of a number bigger than 1. 2. Plug in 2. 6 plus 2 is positive. 2 minus 1 is positive. Positive times positive is positive. So I don't care which way you do, but you need to end up with plus minus plus. And now answer the question. Less than 0. Less than 0 means below the x-axis or negative. So the answer would be between negative 2/3 or 1. Or you could write your answer like this. Which way do you like better? I don't care which way you write it because they both mean the same thing. Okay? And then the last problem. See, you could finish the test in 30 minutes. Look, Mr. Park, you already made one side 0. You're welcome. Okay, is that factorable or do I have to use the quadratic formula? It's factorable, muchacho. What's muchacho? 3 and 5, plus and minus. Did I do that correctly? Mm-hmm. Yes, because I'm the teacher, right? We make a number line. What goes on the number line? Negative 3 and 5 halves. Okay, let's see if we can just do this without even doing anything. How do I know it's plus minus plus?
Opens up.
Because yeah, the parabola opens up. So if it opens upward, above, below, above, right? What if that was a negative sign there? That would be minus plus minus, right? But it's not. So we're looking for greater than or equal to 0. So that means where is the graph above or touching the x-axis? So that would be negative 3 to the left. So negative infinity to negative 3. And then from 5 halves to the right. So including now. See, because if you forget to put the brackets, that's where some of you will lose points. Or you could just write x is less than or equal to negative 3, or x is greater than or equal to 5 halves. Now, does everybody understand when to use the word or and when to use that symbol there, which means union? Okay, well, when you use interval notation, then you use U, which stands for union. When you have it written like this, then you use the word or. But you know what? We're Algebra 2B, we're not Algebra 2 honors, yeah? So, if you don't know, see like in calculus, I teach calculus, there's a difference between BC and AB. BC is like honors calculus. Then you're expected to do it the right way. But in AB, I tell them, if you don't know, just put a comma. I'll give you full credit. But I'm trying to teach you proper mathematics. Okay, so tomorrow's test, this is the easiest of the 3 tests because first of all, it only has 3 sections it covers, right? So we want to get a good score so that we can get off to a good start because then the other chapters are going to be a little tougher. So it's going to be harder. But I'm going to try and help you out the best I can. I'm going to give you practice tests, practice quiz, whatever. Okay, any last questions on this?
So
Yes.
to solve the inequality, you want us to graph it on a line.
No, I want you to know. This is the answer then. Either this number line is to help you get the answer. Yeah. So if you just did this, and like if this problem was worth 8 points, yeah, but see, you didn't answer the question though, right? So minus 3, 4, or 5. Okay, if I'm having a good day, minus 4. But then if like I'm all grouchy and then like for lunch all I had was stale graham crackers, minus 5 or 6 even. No, you gotta answer the question, right?
Yeah.
You gotta answer the question. Okay, so like over here, either this is the answer or that is the answer. All right, today we gotta learn now. So tonight's homework is, I guess, you just study for the test, right? But if you did the practice test, no need, right? You're ready already. Tomorrow night's homework, when do I meet you next? Do we meet on Friday?
Tuesday.
No, because then, so I don't meet you on Friday, Monday's a holiday, so I don't even see you till Tuesday then. Oh yeah, Mr. Park, I have to do nothing till Tuesday morning. Is that what you're thinking? You guys are sad. Whatever, as long as you get the job done, right? Okay, so today we're going to move on to section 5, chapter 5. So now, functions are not going to be parabolas. So here's your assignment sheet. So you're right, I don't see you till Tuesday. And look, I gave you some little bit problems. Come on, it's like I did something. Okay, so what I'm going to do is I'll just do examples that are just like the ones in the book and make it easy for you. Okay, does everybody have their book? Or do I have to take off points?
I don't have my book.
Minus 1 for each page missing. How many pages are there? Oh, don't worry, there's only 900 something. You're supposed to bring your book every day. Why, when I can just take a picture of yours, Mr. Park? You guys are sad. Yes.
Start to take a picture of your own book.
That's fine. No, because, yeah, well, see, we got the camera rolling now, but they told us don't let students take pictures of your book because of copywriting issues, right? But if you already bought your book, you can take a picture of your own book, right? That's all I'll say. The camera was rolling. Okay, so today we are starting to study polynomial functions. Now, do you guys know what a polynomial is? Okay, I'm going to give you an example of a function, and you tell me if it's a polynomial or not. F of x is equal to... Wait, wasn't it you who told me to videotape today?
No.
Or was somebody else? Must be from the class. Okay, what about a linear function? Is a linear function a polynomial function?
Whoa.
Yes, it is. You get, what, 50-50 chance? 50-50 chance, like, Mr. Park doesn't think I'm smart. What about a quadratic function? You know, the parabolas and stuff? Is that a polynomial function? Yes. Now, if you guys actually read the book, do you guys even read the book at all? A polynomial function is a function that has whole number exponents on the x's. You guys know what whole numbers are? What is the smallest whole number? 0, that's right, see? Like here. Isn't that like x to the 0 power right there? Because what is x to the 0 power? It rhymes with 1. 1. So anytime you just have x's with only whole number powers, then that's a polynomial function. So what about something like this? 2x cubed plus 3x squared plus 5x plus 7. Is that a polynomial? Yeah, because all the powers of x's are whole numbers. 0, 1, 2, 3, 4, and so forth. So if you had a polynomial function like this, you got to know certain things like, what is the degree of the polynomial? Degree means the highest power there. So what is the degree of this polynomial? 3, because that's the highest power. What is the leading coefficient? 2. So this is called, we call this the leading term, or we call it the cubic term. This is called the quadratic term, right? Because like quadratic function. This is called the linear term. And this last one here is called the, just like over here. That's called the, it rhymes with constant. A constant term. So of course, what you could have higher degrees. So here, let's m of x is equal to 4x to the 6 plus 3x to the 4 plus 2x cubed minus 5. What is the degree of this polynomial? 6. That's the highest power. What is the leading coefficient? Yeah, 4. Leading coefficient. What is the coefficient of the cubic term? What's the cubic term? Well, this one, see, x cubed. What's the coefficient? 2. What's the coefficient of the quartic term? 3. What's the coefficient of the quintic term? What do you think quintic would be? 5. But there is no fifth power, so what's the coefficient? No, 0. 0. Because isn't that like the same thing as 0x to the fifth? What is the coefficient of the quadratic term? 0. What's the coefficient of the linear term? 0. What is the constant term? -5. See? Easy. Yeah, but see, you guys got to be able to graph these. That's what we're getting to. If I give you a polynomial function, you have to be able to graph it. All right. Okay. What about this? X squared plus 2x plus 3 plus the square root of x. Is this a polynomial function? Now, what did I tell you? All the powers of x have to be whole numbers. Now, isn't the square root of x the same thing as x to the 1/2 power? You guys learned that, right? 1/2 power means square root. Is that a whole number? No. The whole numbers are, if you forgot, 0, 1, 2, 3, dot, dot, dot. These are the whole numbers. So if you have a power there that's not a whole number, it's not, so this is not a polynomial function. What about this? 3x plus 5 minus 1 over x. Is this a polynomial function?
Yeah.
No, because of this. That is the same thing as x to the what power? -1. Is -1 a whole number? Wait, let me look at the list. Is -1 on this list? Took you guys that long? Is -1 in this list? Wait, let me get my calculator. No! So because of this, this is not a polynomial. You can only have whole number powers. You guys understand? Okay, so tonight's homework, basically you gotta learn how to graph these things. Okay? This is easy, okay? You know what? I'm gonna give you, you know what? I'm not gonna even follow these examples. I'm just gonna think of my own way. It's easier that way. Okay, what time does this class end? Hopefully we can end 15 minutes early. What is this period? 11:15? Okay, 5 of you? Okay, here. So this is tonight's goal. You gotta be able to graph polynomial functions. Okay, y equals x plus 2 times x minus 1 times x minus 3. Graph that. See now, last chapter you would just have that, right? There's only 2 x-intercepts, but then now you can have more than 2. Okay, so when you graph polynomial functions, the first thing you do is plot the x-intercept and the y-intercept. Okay, so here we go. How do you find x-intercept? What do you do? You set y equal to 0. Now, so what are the solutions to this? See how it's all nice and factored? What are the solutions? -2, 1, and 3. So if it's in factored form, it's kind of telling you what the x-intercepts are. The x-intercepts are -2, 1, and 3. How do you find the y-intercept? You plug in 0 for x, okay? If I plug in 0 for x, what are you going to get? 0 plus 2 is 2. 0 minus 1 is -1. 0 minus 3 is -3. Multiply that together, what do you got? It rhymes with mix. Are you serious? You cannot multiply 3 numbers? My dog can do that. Okay, so we know our graph has to pass through those 3 points. Okay, now I'm going to teach you some things which they teach you in the book. Okay, now if I were to multiply this all out, what would be the degree of this polynomial? What would be the highest power there? Would it be x to the 3rd power if I multiply it all out? So this is a 3rd degree polynomial. Anytime you have an odd degree polynomial, this is all in the book. You don't have to write this out. It's all in the book. I need to write it down. If you have an odd degree polynomial and the leading coefficient is positive, then the end behavior is going to be like this. That means on the outside, the graph is going to explode down that way, and then on this side, it's going to explode up that way. Like, you know how parabolas are? Parabolas, like when they open up, the end behavior is either like that, or like that. But that's when you have a parabola, when you have second power, right? But now, if you have an odd degree polynomial and the leading coefficient is negative, then it's just going to be the opposite way. It's going to be like this. They have this picture in the book, you know. Did anybody even look at the book? They have these arrows. Some people have their books. Whatever. If you have an even degree polynomial, leading coefficient positive, then the end behavior is like this. And if you have an even degree polynomial and the leading coefficient is negative, then it's like that. And you know how these are easy because just think of y equal x squared. What does the graph of y equal x squared look like? What does the graph of y equal negative x squared look like? And then, you know, for these, you know what you think of? Just think of y equal x to the first power. What does the graph of y equal x look like? Doesn't it look like that? Y equal x. See? And then what if the leading coefficient is negative? Think of y equal negative x. What does the graph of y equal negative x look like? Yeah? So that's an easy way to remember. Just think of x to the first and x to the second. Okay, now, since you told me that this degree is 3, it's odd, right? And if I were to multiply it all out, what would be the very first term? What would be the first term? Wouldn't it be 1x cubed? See how the leading coefficient is positive? So leading coefficient positive, odd degree. Oh, I erased it. It means end behavior is going to look like this. Okay, so that means on the outside of the graph will be going like this. So that means over here, I know the graph is exploding downward. Okay? Now, I'm drawing the graph. Now I'm coming up to this x-intercept. Now there's two possibilities. Do I go through it, or do I bounce off? How do you tell? Well, -2 came from this factor. It has an odd power on it. If there's an odd power on it, it's going to go through. Anyway, if you just use common sense, look, if you bounced off it, how are you going to get to the y-intercept up there? You're going to go through again, but there's no x-intercept here. So the only way the graph is going to make sense is it has to go through. Okay? I've got to hit the y-intercept. Now I'm coming up to this x-intercept, 1. 1 came from this factor, right? It has an odd power. So what do you think? Go through it or bounce off? You go through it. Okay, now I'm coming up to this other x-intercept, which is 3. It came from here. It has an odd power, so what do you think is going to happen? It's going to go through, and that's how you get the end behavior. See how the end behavior is like that? Now the next question you're going to ask me. So, well, let me ask you a true-false question. True or false? This minimum point over here is halfway in between here. True. False. Like if this was a parabola, yes, the vertex occurs halfway in between. But once the power becomes 3 or bigger, then it's not. So it's somewhere close, but it's not going to be exactly. Same thing over here. You know the maximum point up here is going to occur somewhere near the halfway point, but it's not going to be exact. Anyway, in this class, I only want you to draw a sketch. We're not going to draw like exact graphs. So that's what I want from you, okay? But I want you to be able to do this very quickly, like 15 seconds. Okay, now, you guys think you're good, yeah? You think you're good? Okay, I'm going to make it a little tougher. I'm going to put an even power on one of these. Which one? Pick one. Pick one. First one. Okay, the first one. I'm going to put, I'll make one, put 3 on. Okay, there. Is this graph going to look the same? No, don't be ridiculous. Okay, so first of all, if I were to multiply out everything, what would be the very first term? X to the... No, look, because it gets 6 6. How come? Because if you were to multiply this out, wouldn't the first term be x squared? You multiply this out, the first term would be x cubed, right? And then this one is x. What happens when you multiply x squared times x cubed times x to the first? You add the exponents, you get x to the 6th. So this is a 6-degree polynomial. That's even. The leading coefficient is positive. So what's the end behavior? I'll give you a choice. A, B, C, or D. I taught it to you. Look at your notes. Or look at the book. A, B, C, or D.
C.
C. If it's an even one, then it's either like that or like that, right? Remember I told you think of y equal x squared? And then since the leading coefficient is positive, just think of y equal x squared. Looks like that, right? So the end behavior is going to be like this. That's the end behavior. Okay. So here we go. Now we are ready to draw the graph. What are the x-intercepts? Are the x-intercepts of this graph the same as this one? Is it still -2, 1, and 3? Yes, because to find the x-intercepts, you would set y equal to 0. What makes this equation 0? -2, 1, and 3. Yeah. Is the y-intercept still 6 though? How do you find the y-intercept? What do? You plug in 0 for x. So if I plug in 0, you get 0 plus 2 is 2, but then you got to square it. What is 2 squared? 4. Plug in 0 here. 0 minus 1 is -1 cubed. -1. And then 0 minus 3 is -3. Multiplied it together, what do you got? 12. So it's not changing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if that's what you want to do, that's fine. But you know what I do? This is what I do. 12. Bad. Change the scaling. And remember what I told you? If you don't write anything, then I just assume each one is 1 unit, right? So if it's 1 unit, fine. But if you're going to change the scaling, just put one thing there. If you want to do that, okay, if you want to do this, that just means each hash mark is 6 units. Right? Whatever. But you don't have to make 12. Because what if the y-intercept was 200 something? You can make 200 something hash marks. I have no doubt some of you would do that. Okay, now, what did we say the end behavior is? It's like this. So on the outsides of the graph, it's going to be like this and like that. That's the outside of the graph. Okay. Now, the graph is coming down. I'm coming up to this x-intercept. What do? Do I go through it or do I bounce off? Well, -2 came from here. It has an even power. If you have an even power, the thing bounces off. Odd power, the graph goes through. That's the difference. Okay, then it goes up, and now it's going to start coming down. See, so you know it's going to hit this maximum point, but somewhere near the halfway mark, but not exactly. Okay, now I'm coming up to this one. Do I go through it, or do I bounce off? The x-intercept of 1 comes from this factor. See how there's an odd power? So do I bounce off or go through? You go through. Even power bounce off, odd power go through. But when you go through, see, when you have a first power, see how it just goes straight through like that? When the power gets bigger, this is what happens. It goes through, but it kind of flattens out like that. You'll tell me why next week, or next class. Okay, now, it'll hit the minimum point somewhere near the halfway mark. Now it's going to go up. Now what? I'm approaching this x-intercept. Do I go through it or bounce off? You go through. How come? Because this x-intercept came from this factor, has an odd power, and it's 1, so you just go straight through. And see how the end behavior goes up like that? Does this all make sense? Yeah. So, the difference between first power and third power, they both go through, but one goes like this, the other one flattens out. So what would happen if you had like 5th power or 7th power? What would happen? It would just flatten out even more. But in this class, I'm not going to give you 5th or 7th power. It's just going to be 1 or 3. Okay, you don't have to worry. And then, what if you had a 2nd power? See how it bounces off like that? What if you had a 4th power? The thing would just flatten out even more. But you don't have to know that. You just, in this class, since we're only 2B, you just have to know the difference between first power, second power, third power. You guys get it? All right, so you should be able to do all the homework problems based on this. If not, ask questions next week, Tuesday. Yeah, but you know what the problem is if you only do the homework Tuesday morning, what's gonna happen? I forgot what Mr. Park taught me. Then you can watch this video, because every time I make a video, do you know it's posted on the website? Yes or no?
Yes.
I don't believe you. See, look, yesterday's video discussed 4.5 is right there. All right, this period, I forget what, 15, okay, oh, we only have 7 minutes remaining. Woo-hoo. Yep. So you want to ace tomorrow's test, just make sure